In the previous lesson, we looked at volume as a function of height. And what we saw was that if I double the height of a cylinder, it would also double the volume. For this lesson, we're going to look at volume as a function of the radius. And we're going to see that that acts a little bit differently. So the first part of this problem asks us to write an equation that expresses the relationship between volume and radius. And we'll use 3.14 as an approximation for pi. So that equation is going to be volume equals, remember with a cone we have to do 1/3 times the volume of the cylinder. So to find the volume of the cylinder, I need 3.14. Go ahead and put multiplication in there. 3.14 times the radius times the radius times the height, which in this case is 7. What we're going to do is come up with a formula. We'll simplify this and we'll end up with volume equals something times radius squared. Then what you're going to do is predict what would happen if you tripled the value of R. So if R is 1, I'll have a certain volume. What if R is 3? What happens to the volume? Does it get 3 times as big? I'm sure you figured out it does something a little different. So we're going to use this tool to graph some of those points and then see what happens to the graph. I'm sure you've already figured out it's not going to be a straight line, but what does happen to the volume when I change the height? And what we're looking for, there is a rule that whatever factor I use on the radius, there's a rule that I apply to that factor to figure out the factor for the volume.